electric dust devils on Mars. In the scheme of things, dust devils on Earth have always been treated as a trivial phenomenon, with little to do with their larger cousin, the tornado. However, this perception starts to get fuzzy when we take a look at the monster whirlwinds of Mars. Conventional explanations seem to fall short when it comes to explaining the astonishing power and size of these Martian giants. The simplest solution to this enigma may be the electric one. Meteorologists think the atmospheric forces that generate dust devils and tornadoes don't have much in common, appearances aside. After all, tornadoes don't happen in dry, clear air, and dust devils don't tower miles over the surface, unless you're over on Mars. Take a peek at the red planet, and there's a good chance you'll see any number of titanic dust devils tearing dendritic pathways over the plains, some as big as Mount Everest. So far, there's been no solid solution to explain how any dust devil can reach these sizes. Thanks to recent discoveries made by investigators in Arizona and Nevada, some clues to this mystery have been uncovered. It turns out that dust devils have a powerful electric field, often exceeding 4,000 volts per meter. For meteorologists, these discoveries likely came as a shock, pardon the pun, especially when you consider that the thermal and mechanical models currently accepted for dust devils and tornadoes did not predict and do not include these electric fields. Let's dive in and take a look at the Martian Twister. Even compared to our biggest tornadoes, the dust devils on Mars are enormous. They can be 5 times the diameter of terrestrial twisters, stretching upwards of 5 miles over the Martian surface and achieving things that traditional meteorology considers impossible in the nearly airless environment of Mars. Impossible because, according to mainstream understanding, they can't be tornadoes since there's no water-laden clouds on Mars, and they're just too big to be dust devils. You can't blame them for thinking this. After all, according to the conventional model they use, dust devils form when pockets of warm air rise and interfere with each other, sometimes causing one pocket or another to begin a swirling motion. From a story at Space.com, paraphrasing the work of William Farrell of NASA's Goddard Space Flight Center and his research team. So let's play this out. Just like on Earth, Martian dust devils form when the ground heats up during the day and warms the air just over the surface. Fair enough? Next, these pockets of air bump into each other and can sometimes start a swirling motion for reasons. Alright? But you have to wonder, how does rising warm air pockets, randomly interfering with each other, explain the gargantuan twisters, crackling in electricity and spinning with the terrifying rotational forces that we see on the monster Martian variety? The atmospheric density of Mars is only 1% of Earth's. How could a Martian wind possibly generate the kinds of force needed to tear the giant dark tracts of land left in the wake of these things? That'd be like trying to hit a home run using a spaghetti noodle instead of a bat. These things are causing such havoc we can see the trails they leave behind from space, and that's not even mentioning the titanic global dust storms. I mean, I'm no Don Scott, but clearly there's something missing from the equation. But let's give them the benefit of the doubt and assume it really is pockets of air interfering with each other that is somehow creating the levels of power we see from these things. But if so, how does the dust devil's close cousin, the waterspout, start its rotation well beneath the water's surface? I don't think there's any colliding air pockets floating around down there. In fact, the first thing you see in a forming waterspout is a circular white spot, surrounded by an irregular dark area on the water's surface. Next comes a pattern of light and dark bands spiraling outwards, and then a dense swirling ring of spray called a cascade. Now this appears around the dark spot and rises toward the clouds. Whatever's doing that, it isn't colliding air pockets. So let's pencil in electricity and see what turns up. We'll start with a breakthrough in understanding waterspouts from the work of Russian plasma physicist V.A. Ranstev-Karnatov. He concluded these phenomena are the product of long-lasting discharge between the plasma networks of an ocean or lake surface and the electrical charge of the clouds above. Plasma discharge behavior explains the rotation in the narrow, coherent, and undulating funnels of waterspouts succinctly. Take a look at Picture of the Day, October 29th of 2004, Electric Waterspouts for a deeper dive. Begs the question, what if waterspouts, dust devils, and tornadoes actually form the same way? Well, way back in July of 1999, Wal Thornhill wrote, "The 5-mile-high dust devils on Mars and the global Martian dust storms are, I believe, a manifestation of electric discharges on Mars. Make no mistake, the Martian dust devils are tornadoes that dwarf their earthly counterpart. Clouds are not required to generate them. They are an atmospheric electric discharge phenomenon." Dr. William Farrell of NASA's Goddard Space Flight Center reports,
"If Martian dust devils are highly electrified, as our research suggests, they might give rise to increased discharge or arcing in the low-pressure Martian atmosphere."
According to Thornhill, such arcing in the rarefied atmosphere of Mars would have the appearances of a glow discharge, not unlike that of a lightning sprite above terrestrial thunderstorms. Like I mentioned earlier, another telltale sign of the electrical power of these twisters are the dark trails they leave across the plains when they pass. Jupiter's moon Europa comes to mind. Experiments with laboratory arcs have shown that these discharges will burn soil as they pass. And if these dark areas are crossed again, the burned soil can be blown away, revealing lighter soil beneath that hasn't been burned. While some mainstream scientists have begun to tepidly embrace electricity as a component of these storms, letting go of the mainstream thermal and mechanical concepts of atmospheric whirlwinds is still a big ask. Most of the new theoretical models of electrified dust devils, for example, think they need to explain a way to separate the charge. Let me explain. Separating charge requires energetic movement and collisions of both large and small soil particles. In these collisions, the larger particles become positively charged, and the smaller ones go negative. After that, it's the power of the wind that separates them into regions of different size, creating an electric field. Okay, but what about on Mars with its cobweb-thin atmosphere? Are we expected to believe that in a near vacuum, large grains of soil were raised miles into the sky with a force sufficient to generate the kinds of voltages we're discussing? To be fair, at least they're recognizing the electricity. But the mistakes mainstream meteorologists make is to follow the cosmologist's notion of an electrically neutral and disconnected universe. That outdated belief is why these guys are forced to invent ad hoc mechanical and thermal explanations whenever they see electrical activity. If you live in an electrically neutral world, something's got to account for the charge separation, right? The idea that our Earth is connected to the circuitry of the Sun, let alone that the Sun is connected to the circuitry of the Milky Way, isn't figured into the standard model of cosmology. But once you understand planet Earth has a huge and well-measured electric field of about 100 volts per meter down at sea level, then you understand there's no need to generate charge separation in a dust devil. The connection between Earth and the ionosphere does that job all by itself. When warm, dry air rises from the surface, that vertical movement of dust passing through the Earth's electric field is what charges the dust particles, forming a weakly ionized plasma. One of the self-organizing characteristics of that plasma is that it naturally shields electric fields within by forming a thin double layer, or sheath. And that's where most of the electric field strength is concentrated. Remember the 4,000 volts per meter we were measuring at the base of these whirlwinds? Things are starting to make a little more sense. Any electric field with that kind of punch down near the planet's surface is more than capable of lifting small charged dust particles and generating a vertical current. Fine, but what about the rotation the mainstream explains away with hot air bumper cars? Well, that's an easy one. Electric currents rotate. We've all seen it in a plasma ball. If you have two electromagnetically induced parallel vertical current streams, you've also got a vortex. From those tiny plasma threads inside the glass ball at your novelty shop up to galactic Birkeland currents that cross the cosmos over hundreds of light years, it's all the same. Electricity scales and currents counter-rotate. Over on Mars, it's no different. The gigantic electrified dust devils are connected to the planet-wide circuits, and those circuits connect Mars to the Sun. There are no storm clouds to distribute and lower charge to the Martian surface. Instead, you get huge diffuse discharges that take place directly between the ionosphere and the surface. These discharges are exactly what forms not only the towering Martian twisters, but are mysterious global dust storms as well. Movement of air and water have nothing to do with charge separation. That's putting the cart before the horse. The separation is already there. It's what's causing the air and water to move, not the other way around. The longer the electric force is ignored, the more the flood of new discoveries being made about our electrical environment will confound and confuse mainstream sciences. You can only invent so many particles, stitch together so many wild physical anomalies to explain away the electrical phenomenon we see all around us. Take the towering columns of upside-down lightning captured by Puerto Rico-based photographer Frankie Lucena on August 20th, 2023, featured on Space.com. He caught them just before the storm evolved into Hurricane Franklin, blasting straight upward out of the storm clouds to the edge of space. A lightning display with 50 times the power of ground-based lightning, stretching 5 miles in length. Space.com had this to say about these giant red jets. Quote, "Still, scientists have known about the phenomenon for only 20 years, and much about it remains a mystery, including why the bolts shoot upward into the sky rather than slashing down to the ground. The gargantuan upward flying bolt may be the result of some kind of blockage that prevents lightning from escaping through the bottom of the cloud," the authors of the 2022 study wrote, but the exact mechanism is still unknown. End quote. Blockage? Like what? Well, Benjamin Franklin demonstrated the electric charge between Earth and the atmosphere with a kite and a key back in 1752. And if we just follow that line of thinking, then giant jets become another predictable and explainable feature of our electric environment. The electric argument proposes that clouds act like one side of a capacitor, while the ground acts like the opposite side. The atmosphere is the dielectric insulator. When the electrical energy between the clouds and the ground overcomes that atmospheric insulator, the opposite charges reach out to each other, forming leader strokes. The electric circuit between ground and clouds is completed when the two connect, allowing bursts of electric charge to flash along a conductive pathway. It's the return stroke, though, that contains the greatest electric charge in lightning, delivering up to 100,000 volts at 100,000 amps. About 10 billion watts or more in a few milliseconds. The Earth-cloud connection is just one capacitor. There's also electrified space. Lightning can interact with charged particles coming from space, otherwise known as cosmic rays. Cosmic rays are mostly protons that impact air molecules, knocking electrons out of their atomic clouds. Lightning flashes, as mentioned, possess powerful electric fields, so free electrons can accelerate through Earth's mesosphere, bridging near-Earth space to the ground. Along with charged particles from the Sun, those electrons are the principal sources for the Van Allen belts. And when conditions are just right, the upper atmosphere can act like a giant particle accelerator above the clouds. And when enough charge builds up, we can see discharge events between cloud tops and the mesosphere, such as red sprites and blue jets. In the most powerful supercell thunderstorms where gigantic jets are formed, we've seen upside-down lightning reaching altitudes of 80 kilometers, near the height of red sprites, discharging at 144 columns into the upper atmosphere within 1 second. For context, regular lightning gives off about 15. Electricity in its many forms is the raw powerhouse force that holds the universe together, creating its galactic structure with the intrinsic self-organizing properties it's been endowed with. It can generate more than enough force to hold galaxies together with no need of hypothetical supercondensed matter. It already works without any sci-fi nonsense to endow it with strength it does not intrinsically possess in order to fit broken, non-predictive computer models. So there it is. Charge differential and the discharge that occurs between Earth and space is the primary driver. Not only Earth's amazing weather phenomenon, but also most of the off-planet weather we see as well. The electric force is the only force present that explains how dust can be lifted in the paper-thin atmosphere of Mars, which is only 1% the density of our own atmosphere here on planet Earth, and spun into the titanic and terrifying Martian twisters and global dust storms that have been confounding the conventional experts of space science for decades. As new discoveries mount, the electrical nature of our universe is getting harder and harder to deny. And Martian dust devils are just the tip of what's turning out to be a very long spear.